Okay, in this video I'm going to do another example of solving a trig equation using a sketch together with a calculator. This follows on from a previous video. This is going to be question number 2 of this particular type of equation that we need to solve. I've got a question on the board. Part A says sketch y equals cos x, notice sketch, for 0 to 360 degrees. So let's do that first. So part A, I need a sketch of a cos x graph. So I'll set up my sketch, a y and x axis. As I mentioned in a previous video, draw the basic shape of the cos graph first, 0 to 360, and then add all the details, the figures on the axes afterwards. So the cos graph starts at a peak right at the top here, and then does a cycle back to the top like so over a 360 degree period. 360 degree cycle. So at the top will be +1, right at the bottom down here will be -1, we know that. And what else do we know? Well, the x values, 0 degrees there, right at the end, if you want to drop a vertical down there, would be 360. Halfway would be where the trough or the bottom of the curve is, that would be 180. And I think it would also help you in these type of equations if you marked on the sketch these two values here, which if you've done it reasonably accurately should be the halfway point's 90, and then halfway between 180 and 360, that would be 270 degrees. So there you go, there is a sketch of y equals cos x between the angles 0 to 360 degrees. And perhaps you should label it y equals cos x in your sketch. So that's part A done. Now in part B it's saying hence. As soon as you see hence, that implies you should use your answer from the previous part to answer this question. So hence solve, and we've got a trig equation to solve. We have got cos of x equals 0.2. Okay, well let me first of all say to you, because we're not using an accurate plot of y equals cos x, I cannot use the graph on its own to get the exact answers. But what I can do is use the sketch, which I've got, in combination with a calculator to get the answers. And this is what I do. I'm going to reach for my calculator and I'm going to say, right, if cos of x equals 0.2, then the angle x will be equal to, right, from my calculator, I'm going to say, to get x, you need to press shift cos of 0.2. So shift cos 0.2 equals, just make sure your calculator is in degree mode as opposed to something like rad mode. That's a very common mistake that people make. Degree mode we're in. And the answer is 78, and to one decimal place it reads 0.5 degrees. So I know the answer is 78.5. Now if you were doing a right angle triangle question using SOHCAHTOA techniques I talked about in earlier videos, then that would be the answer. However, as I explained in the previous video on this work, there will be at least 2 answers for these questions. Let me show you how I locate the second answer. So cos x equals 0.2. If I was to solve this graphically, which is what I need to concentrate on now using my sketch together with the calculator answer, what I would do is plot a graph of y equals cos x. Okay, I'll just write this down here in colour, y equals cos x. Well, I've got that graph, there it is, y equals cos x. It's a sketch, but that's fine, I've got it. Secondly, I would plot a graph of y equals 0.2. Well, I haven't got that. It's a straight line graph, horizontal. So I need to go to point 2, which is about there on my scale, mark on point 2 and draw a horizontal line going across and label it with its equation or its name, y equals 0.2. Now as you can see, the solution to that equation will be the intersection points of those two graphs, the cos graph and the straight line graph I've just drawn, y equals 0.2. So if I now go on and find the intersection points, there's one intersection point there and one intersection point there. I need now to drop vertical lines down and read off the x-axis. They will not give me accurate answers because they keep saying it's a sketch, so there's no point trying to read off accurately from your sketch. However, we do know that one of the answers from this bit of calculator work should be 78.5. Well, if you look at your picture, there is one answer that's a little bit short of 90 degrees. Well, that quite clearly must be the 78.5 degrees that the calculator gives. Now you can quite clearly see that there's a second answer. That second answer we now work out from symmetry of the picture. Now I've got a tiny little area here which is very difficult to show you. Perhaps I should have drawn it a bit bigger, but never mind. I think you can see. Those two little regions are symmetrical from the symmetrical nature of the cos wave. And you can see that that gap that is going from, let me get my pen out, from there to there goes from 78.5, which is that answer, up to 90. Well, if you work out the difference between 78.5 and 90, that's an 11.5 gap from there to there. I find it very difficult to squeeze that on, but I'll write it underneath in quite big writing. 11.5 degrees from there to there. So from symmetry, that gap along the bottom of this little shaded region must also be the same size, 11.5 degrees. Well, if I know that that is 270 and that gap is another 11.5 degrees there, this angle that's missing there will actually be 270 plus 11.5 degrees from the symmetry of the situation. And so the second answer, which I'll put as a comma now, is going to be 270 plus 11, 281.5 degrees is the second answer. The calculator gives you the first, the sketch and the symmetry gives you the second, 281.5. And if you were actually to check, I will check this now, the cos of, well obviously the cos of 78.5 would give an answer of 0.2, but I'll also check now that the cos of 281.5, if I press equals, it actually gives an answer, well, 0.199, which rounded off is exactly the same within a margin of error as 0.2. So it is the correct answer. And there you go. That's question 2 done, solving the equation cos x equals 0.2 using a sketch on the calculator. I want to speed up a little bit now and do a question 3 on this video, because question 3 takes a little bit more thinking about than questions 1 and 2. Okay, so I'll make some space. Question 3. Now at first glance, question 3 is going to look pretty much identical to question 2. I'm going to say 3, part A, sketch y equals cos x, and I'm going to give you 0 to 360 degrees again for the range that I'm going to draw the sketch for. So let's do that very quickly. Here's the sketch, like so, y and x, and the cos graph starts at the top, swings down and then back up to the top. That value is 1, down here is -1, 0 degrees, 180 degrees in the middle there, 360 right at the end, and that point there is 90 if you do it right, and that would be 270. So there you go, there is a sketch of the y equals cos x again. Okay, now what I'm going to do for part B is going to say solve using this sketch. So I'm going to solve an equation using this sketch, and this time I'm going to say cos of x equals minus 0.8. So it's a minus 0.8. So what is the effect now of putting that minus there when I come to solve things? Let me show you how this works. Okay, so if I'm going to solve this, I'm first of all going to use a calculator to give the first answer, and then I'll use sketch with symmetry to find the second answer. At least that's what I'm going to try and do. Let's see what happens when I do this process. So from a calculator, I'm going to reach now for my calculator, and I'm going to press inverse cos, so shift cos of minus 0.8. I'm going to put this inside a bracket now, just in case the calculator doesn't like it, just me putting minus 0.8. I'll put the minus 0.8 in a bracket. So shift cos of minus 0.8, and that works out to be, now you can see, it's 143.1 degrees. from the calculator. Okay, so that's what the calculator gives me. So that, I hope, is going to be one of my answers, which seems fine. So let's actually now use the sketch together with that to see if I can come up with both answers. Okay, so I need to plot a graph of y equals cos x. I've done it for the range given. And I need to also plot a graph of y equals minus 0.8 for the range given. So minus 0.8 is somewhere down here on the axis, the y-axis. And I need now to go a horizontal line across there. That's the graph y equals minus 0.8. You can see I've got two intersection points, one there and one there, so there will be two solutions. And I need now to draw a vertical line going up this time to the x-axis to read off the two values. I can't read them off directly because the graph isn't accurate, so I make use of this answer together with symmetry to get both of the answers to the equation. Well, looking at this one here tells me the answer, this answer refers to something which is a fair bit bigger than 90. It lies between 90 and 180. Well, 143.1 is actually going to be that reading. That is the reading that this first answer refers to, 143.1. So that's fine, that's the first answer. Now the second answer comes from this reading. Now that reading must be obtained from symmetry. Okay, so from symmetry, let's have a look at the situation. I've got this portion of the graph, which from symmetry you can see is the same as that portion of the graph. That reading there is 143.1 and that reading there is 90. So the gap between them, just take them away, is 53.1 degrees. So that must mean that that gap from symmetry from there to there is also 53.1 degrees. Fine, well, I know that that reading there at the end there is 270. So what I need to do is subtract 53.1 off 270 to get this reading here. So if I take away 50 off 270, you get 220. Take another 3, I'll get 217. Take another 0.1, I'll get 216.9. So that reading there on that scale is 216.9 degrees. So that's 216.9, that's 270. The gap between them is 53.1, the same as this gap between over here from symmetry. So the second answer for this particular equation, which I'll now put as a comma, is 216.9 degrees. And there you go, both of those lie within the range 0 to 360. I'll just quickly check that that second one is correct. What I'll do is I'll put cos, I'll put in that value into here to check it works. So the cos of 216.9 is equal to, and you get an answer of minus 0.79968, which within the bounds of the approximation I've been making is minus 0.8. So it is the correct answer. So there you go. There's two more questions of using a sketch of a trig function to solve an equation with the aid of a calculator. That's the end of this short video. In the next one, I'll do another couple of examples, and there's going to be slight complications, but that's for the next video.